I wrote down here, first of all, this is section 9.2. I'm skipping 9.1. I'm going to do that second because I think it works better that way. We'll see. You guys can give me some feedback. And Cole, you can see I wrote you need a calculator. A phone won't be acceptable. So get in the habit for the next few days of bringing a calculator. It's mostly going to be timesing and dividing, a tiny bit of squaring and square rooting. If you can do them in your head, you're fine, but I'm not going to try and make them work out evenly. It's too much work. So use your calculator. Recall from Ohm's law. What did V stand for? What was the equation? V equals I times R. What did I equal as an equation? V over R. What did R equal as an equation? I think V over I. Yes? And I wrote down, hey, you can get these from your formula sheet. I just want you to be aware that those are out there and on your sheet. So just to apply this then, because I don't think the textbook really gets into some cool applications. An electric motor has a resistance of 12 ohms, and it draws 8 amps of current. What's the minimum voltage required to run it? So I gave you this acronym last class, but we're going to formalize it. The acronym that I use, Brady, is something that I call DFIC. I stole this from another teacher, where D stands for list your data, F stands for find a formula, I stands for insert the numbers, and C stands for calculate, or I usually just say crunch the answer because that's just a mathy term. So you ready? Brady, I'm coming back to you. Part A, what's it asking me to find? The required what? The required what? Voltage. The nice thing, these are technically word problems, but I've argued in science word problems are way easier because it's pretty obvious what they're asking you to find. Voltage. My approach then, I go like this. I always write down what they're asking me to find, and I put a question mark next to it. Why? It takes 1 second, but I'm telling you, Mandy, the fact that I've written something down, that it's no longer blank, I've learned I'm way more relaxed. My odds of solving this have just gone way up. I don't know why, but I've noticed that with students too. Then I go back and I look at the question. And Brady, what I'm looking for are numbers. And if I had you in physics, I'd also say, and physicsy words. But for now, we're looking for numbers. See the question? What's the first number you run into? What is that? 12 what? This is why I told you it's worth memorizing units. What is that 12? Voltage, current, or resistance? And here's the question. What do ohms measure? Is current measured in ohms? So you want to memorize this because you're sadly incorrect. What is this a measure of, folks? Resistance. So you want to memorize resistance is ohms. It's ohms. It's ohms. Okay, dumb joke. So you know what, Brady? Let's write this. R equals 12. If you want to, you can put the ohms next to it. You don't have to. Some teachers are really fussy that way. I'm not. Keep reading. What's the next number you run into? What are the units next to that 8? What does the A stand for? Amps. What amps a measure of? And this is why I'm big on, as much as I hate memorizing useless stuff, units are worth memorizing. They are useful because they really cut down on your thinking. Now I would say to you, I'm looking for an equation that has a V and an I and an R in it, and I'd like the V to be by itself. Martin, which equation has a V and an I and an R in it?
V I times R.
V equals I times R?
Yeah.
This is the formula. In physics, I usually tell my kids I'll give them half the marks just for finding the correct equation, because that's half the battle. The rest, honestly, is Math 9 substitution plug and chug. Brady, coming back to you, it says insert the numbers. Brady, what number am I going to put in for the letter I? Do you see why I listed the data like that? Because now it really cuts down on my thinking. I can't call it a no-brainer. You have to know substitution in math. But it's as close to a no-brainer as I can make it. You said 8? And what's R? The minimum voltage that I need to run this motor is 8 times 12, which is what? 96 volts? This would be tough to run from a battery. Do you remember how big were the standard batteries? How many volts? Do you remember? Get 1.5. Car batteries are 12 volts. So you could wire, I kid you not, 8 car batteries together. Oh, you know what? 120 volts comes out of the plugs. You'd prefer to run it from a plug. By the way, that's a fib. It's actually 113.4 volts, but we round it to 120 because that's a nice number to do physics with. So anyways, you want to run that from a plug. Oh, crunch the answer. You know what? I did right there. Yeah. Some people do this. When people score a touchdown, they like to spike the ball. When people hit a home run, they do the home run trot. Some people, when you get the answer, this is kind of my touchdown dance. I put a box around it. I don't usually do that in Science 9 because the physics isn't that tough. But in Physics 12, when I've done that question that's taken a whole page and a half, you better believe once I find that answer, I draw a big touchdown box around it because holy smokes, that took a while. It's up to you. So, if a standard house outlet can supply 120 volts, could this motor run from a standard outlet? Yeah. Could you run 2 motors? Well, you guys don't yet know how voltage works. So eventually I will be able to ask you that, and instead of saying no or yeah, you'll be able to answer with authority. It depends on how you wire the motors together, which is really the answer. Depends on whether you wire them in parallel or in series. A blow dryer has a resistance of 13 ohms. If it's plugged into a 120 V outlet, Mason, what's part A asking me to find? How many amps? Now, I'm going to come back to you, Brady. What do I measure in amps? Do I measure volts in amps? No, we can, because remember, volts is volt. That's the easy one. So, folks, what do I measure in amps? Current. I equals question mark. Now, Mason, I go back and I look for numbers. See the question? What's the first number you run into in the question? No, there's one before that. What is that 13, folks? Oh, what's this a symbol for, Mason? That little funky thing. Resistance. Ohms is the units. So if I hear you correctly, Mason, you're telling me I'd do that, yes? What's that 120? How do you know? It's worth, again, don't get me wrong, but I'm going to emphasize, it really is worth memorizing what units go with what. You'll notice, Alec, this time I got lazy. I didn't write the units next to each one. You can! Mason, I'm looking for an equation that has an I and a V and an R in it, and I want the I by itself. On your purple sheet, which equation is that? Find it. He's hunting. Can you say it, by the way, people have said V, I, R, I, V over. Can you say equals? Because there's an equals sign there. Isn't it I equals V over? And by the way, I'm fussy on that because an equation has 2 sides, and that's important. So read it out to me nice and loud and proud.
I equals V over R.
Get a little nerdy adrenaline rush? You should have. Now, insert, plug and chug, as I like to say. What did you say the voltage was, Mason? Over, which means divided by. What did you say the resistance was? What's the answer? Sorry? 9.2 what? What? No, sorry. First of all, one of the things we're going to ask is, Mr. Dewick, when it doesn't work out evenly, what do I round off to? I would probably stop there because there's a lovely 0 there. I might be tempted to say 9.23. There are actually rules for rounding off. They're called significant figures. You'll learn them in Chem 11 or Physics 11. There's actually rules. Depends how accurate your device is. If your device is really inaccurate, you can't carry many decimals because they're all garbage anyways. If your device is really accurate, you can go to like 9 or 10 decimal places. So we're not going to get into that this year. I would take 9.2. I would take 9.23. I would take 9.231. Why wouldn't I take 9.230? Should that 0 stay as 0? What's next to the 0? A 7, which means it would be. So round off properly if you're going to round off. When in doubt, 2 decimal places is usually pretty good. And then, Hannah, what'd you say? I'm fussy on this. Units. Okay? So tensei, your final step, Josh, you go back and check the units. Mason, what did you say we were trying to find? There's a question mark next to it, which is why I did that. What do you say we're trying to find? Current amps. Okay? If you just write a number, I will take a half mark off. Units. That's a review for Christian and for Maddie of what we did last day. Problem. Most appliances don't tell you their voltage or their resistance or their current. Instead, most appliances tell you their power. Measured in? Anybody know what we measure power in? Power is measured in what? Power is measured in what? Yes, it's a dumb joke, but yeah, watts. Named after a scientist whose last name was? Really an overrated scientist, James Watt. If you have me for physics 11 and physics 12, you'll hear me go on a rant about how they really shouldn't have named this unit after him. They should have named it after somebody who did more. But what he was a very good promoter. What is power? Turns out power is the rate at which electrical energy is transformed into other types of energy, usually heat. Power is how fast the object uses energy. By the way, when you get tired, it's not because you're using lots of energy, it's because you're using lots of energy quickly. You're generating lots of power. It's the difference between walking up a set of stairs and running up a set of stairs. Both require the same amount of energy, but the running tires you out because you did it quicker. You generated more power, in case you're wondering the difference between the two. Little trivia for you. For your household appliances, the more heat your appliance moves around, the more watts it's going to have, the more power it's going to require. So here's what I have. We're just going to use our inductive reasoning. I have a bunch of appliances on the left. I have a bunch of wattages on the right. We're going to see if we can mix and match correctly just from what we know of how appliances work. So looking at this list, which of these do you think moves the most heat? And your hint is, if you pull it away from the wall, you'll notice it actually has a special outlet that it plugs into, different from all the rest. I heard it. Loud and proud. Stove. You stop clicking the pen? Thank you. Stove. So, do I have stove on here? There's two appliances that have special outlets. Stove is one. If you ever pull your stove off the wall, you'll see it's this huge, massive round cord. There's one more appliance that moves so much heat around that it has a special plug. No, microwave plugs into regular plug. Loud and proud. It's your clothes dryer. You have no idea how much power your clothes dryer, but wait, think about it. It's got to evaporate a whole bunch of water. It's got to move a lot of heat. On this list, the clothes dryer has the highest wattage. What's the highest wattage here? Put a little 4,800 and then cross that out. By the way, I'm not going to make you memorize this, but this is just, I'd like to give you an idea of what a big wattage is, clothes dryer, what a small wattage is. Okay. What do you think moves the next largest amount of heat from these appliances here? Since stove's not on here, coal, can't use that one. Hot water heater is your next one. Your hot water heater takes around that many, around 3,000 watts, give or take. Depends how big it is. Depends whether it's a gas heater or an electric heater. Which of these uses the least power? And your hint is it can run off of a tiny battery for almost a whole year. Yeah, my little wall clock back there, I change the battery maybe every year, and it's only a little tiny one which doesn't have much charge. So how many watts of power does a clock run? I'm going to ask you the same question. I'm just going to phrase it differently. I'm looking for a slightly different answer. How much heat does that clock give off? Pretty much nothing. Okay. Oh, you know what? I know the wattage of an average light bulb because I've replaced light bulbs. What's the wattage of an average light bulb? 60 is 60 there? Yep, I'll go with that. We have computer, microwave, and kitchen fan. Which of those three gets the least hot, generates the least heat? Maddie, you're right. Have you ever touched the motor of the kitchen, of like the fans in the summer? They're a tiny bit warm, but not hot, 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 hot. But yeah, they do generate a little bit of heat. So what do you think the wattage of a kitchen fan is? 150? Computer or microwave? Now, I said a large microwave. This, by the way, is why if you look at the instructions on microwaving something, they always say microwave times may vary. Because small microwaves have a different wattage, can move a different amount of heat than large microwaves. Anybody know what the wattage of a large microwave is? 10, say that's a long blink. You going to make it? You awake? Okay. Okay. Large microwave typically has a little over 1,000. 1.2 kilowatts, if you wanted to write it that way. How many watts of power does a standard computer take? And again, it varies how old your machine is because chips are becoming more efficient, but yeah, about 800 watts. Evan, do you need to memorize any of those? Say no. What I do want you to know is the more watts, the more heat is being moved. So appliances that move a lot of heat need a lot of watts. That's really what I want you to take out of it. Appliances that run very, very cool don't need many watts of power, like the little wall clock behind me. So, an appliance that has a higher power rating uses more energy or less energy? More. In 1 hour, or 1 minute, or 1 second, than an appliance with a lower power rating. Power is the rate at which energy is used up. As an equation, we write this. Power is energy divided by time. Is that on your formula sheet somewhere? It is? Okay, but you'll notice what I haven't put on your formula sheet is what each of these letters mean. This is the part that you'll have to figure out and commit to memory, and I'm okay with that. P is power, yay. E is the amount of energy used. And T is time. Measured in what? Seconds. If I give you the time in minutes, how do you go from minutes to seconds? Times by 60. If I give you the time in hours, first you go to minutes, times by 60, then you go to seconds, times by 60 again. Okay? Units. Power is measured in what? And the symbol for a watt is a capital W. Oh, what do I measure energy in? What are the units for energy? I gave you a letter, J. J stands for joules, Joules, named after a scientist whose last name was Joule. In fact, he's even got a law named after him. Does anybody know what Joule's first name was? What? What? You're right.
James.
Who said it? Franz, you said it first?
No.
You said it first? Who whispered it quietly there? Who was clever enough to clue in that it's sitting right there? Look. In 1840, a scientist named who?
James.
People. Found how to calculate electrical power. Okay? This is the general formula for power. This is how you can calculate, for example, if you have me in physics, we'll actually calculate how much power you generate running up the stairs. This is the universal form of power. Electrical power, it turns out, is the voltage times the current. It's VI. Where P is the electrical power in watts, V is the voltage drop through the resistor in volts. What do I measure current in? How'd you figure that out? Oh, you read, right? Come on. Okay. Again, it's worth memorizing what units go with what. By the way, Ohm's law is V equals I times R. This equation is actually called Mason. Can you find that equation on your formula sheet somewhere? You guys find it? You know where it is? Okay. In other words, do you have to memorize it? Nope, you got to know what letters mean. You find it, Mason?
No.
Can you help Maddie? Got it? Yeah, you found. I'm just saying. You know where it is.
Yeah.
That's the point. If you can't find it, folks, I'm just going to sit and laugh at you on a test. I'm sorry. It means you haven't done the homework. Okay. Oh, ready? Since V equals I times R and P equals V times I, it also means we can write Joule's law as, do you see how I plugged that in for V? I times R times I. Or I times R. Or, you guys have learned this year, what's a nicer way to write I times I? Squared. Here's another version of Joule's law. This is the one that I actually end up using the most, because usually when I'm looking at a circuit, I happen to know the resistor that I'm looking at, and I happen to know the current that's going through the circuit. Did I give you that one on your formula sheet too? I did. Now, Hannah has a cheap calculator. She's saying, Mr. Dewick, I don't have a squared button, but you can go times itself. In other words, if I tell you the current is 12, some of the people that have the scientific calculators can go 12 squared. You can go 12 times 12. Okay, it's doable. So, Mason, coming back to you, I think you guys have this box on your formula sheet with all these equations, yes? We have Ohm's law, Joule's law, and then the definition of power. Oh, and I also got energy by itself, so you can find out how much energy you're using if you know the power and for how long it's running. Or I can ask you, hey, how long will it need to run for in order to use this much energy? Double check on your formula sheet. Can you find all of the above equations? Yeah? Okay. So we're going to be using that DFIC approach quite a bit. We're going to list our data. We're going to find an equation. We're going to insert. We're going to crunch. Put your pencils down. Look up. You ready? Let's apply some of this. This is how your houses work. If you've ever blown a breaker or had a breaker blow at your house, here's what's going on. Example A says, find the current in your house wires if you plug a 1,400 watt hairdryer into the plug. And I wrote here, remember DFIC. Hey Nick, what's this question asking me to find?
The current.
What variable do I use for current? Let's write down I equals question mark. And then I said we go look for numbers in the question and also on the diagram, Nick. So first of all, in the question, do you see any numbers in the question?
Yeah.
What?
1400
What is that?
watts.
What do I measure in watts? Power. What letter is power? P. What else? I think there's a number on the diagram. Do you see it? Do you see it, Nick?
Yeah.
What?
120.
You know what? The voltage source is 120 volts. By the way, AC stands for alternating current. There's two types of current. There's direct current and alternating current. We'll get into that later. So, Nick, it seems to me I'm looking for an equation that has an I and a P and a V in it, and I'd like the I by itself, because that's what I'm trying to find. Is there one, and can you read it to me? There is one. Find it.
I equals V.
Yep. Where P is 1,400 and where V is 120. How many amps of current are going to go through that circuit, through that blow dryer? How many amps does that blow dryer need to run? 11.7 amps. So here's your first question. Nick, my friend, if a standard household circuit can only apply 15 amps of current, could I plug 2 blow dryers into that outlet? No. What do you think would happen? And this is a safety measure, because if you tried to get more current from those wires would heat up and start a fire. So what you would do is a breaker would blow. You'd hear that, and the power would go out in that system. That's your house's way of saying you're being stupid, you're trying to burn the house down. Please don't do that. You'd have to go then, find where your circuit box is, flip that switch again. How many of you ever done that on a circuit box before? So you know what I'm talking about, okay? In the old days, before we had invented breakers, we actually had fuses, and the fuse would actually melt. So you'd have to unscrew the melted fuse and replace it with a new one before you could get power again. But it was the same idea. It was a safety measure. The only problem was you'd wreck the fuse, you had to replace it, you always had to have fuses on hands. In fact, they used to be called a fuse box. Now we call them a breaker box. Breakers are a better system. Hannah, what's part C asking me to find? Energy. What letter did I say energy was? Hey, let's write down E equals question mark. Have you guys turned the page, or are you on the same page? Then I'm going to relist my data. I think we said the power was 1,400. Yes? We said the voltage was 120. And this question gave me something else. This question here, part C, I see a number. What's that number? Time. Except this is 2 minutes. What did I say time had to be measured in for this to work? How do I go from minutes to second? So I'm going to write here times 60. I think I can do that in my head. 2 minutes, 120 seconds, right? If you can do that in your head, I'm great. You know what? I'm going to say this. In our notes, let's show that so that when you're studying later on, you know what the heck we did. But I always tell my kids, oh, if you can do some of this up here in the homework, I'll give you the answers. I'm going to assume you're not dumb enough just to copy the answers and teach. I'm going to assume you were so good that you could actually get there. That's great. That's called becoming an expert. I'm good with that. So what am I trying to find, Hannah? I'm looking for an equation that has... Pick it up. There we go. You ready? Are you back with me? I'm looking for an equation that has an E in it, preferably by itself. Is there one that has an E by itself? Yeah, what?
Oh. E equals
Do,
E times T.
and you guys have learned in Math 9 that if you put letters side by side, that means times without putting the time symbol in there, yes? Okay. Do I know P?
Yeah.
Do I know T? You notice I didn't bother dropping the current. If I needed the current, I might have also dropped that down. But first I said, let's look at what they gave me. Maybe I can figure it out with that. So it's going to be 1,400 watts of power times 120 seconds. How many joules of energy will I use? Do you get that? 168 with 3 zeros? I think it's 168,000 joules. Or if you're lazy, 168 kilojoules, because doesn't kilo mean 1,000? This is why we start using the prefixes, because who wants to keep having all those zeros kicking around? Is that just a stretch? Okay. So far, so good. Tensei's having a party. Woohoo! Ready, Tensei? Let's plan your party. Tensei has an extension cord. He's plugged it into a 120-volt wall outlet, the same kind we normally have. He's going to have a backyard barbecue, and here's what you want to run. You want to run a 420-watt blender. That's about right for a blender. A 120-watt outdoor projector. These things give off a lot of heat. They take a lot of power. A 900-watt coffee maker. Do coffee makers give off a lot of heat? Yeah, they use a lot of power. And a 660-watt stereo. Complete the following chart. The voltage source is 120 volts. Okay, so the blender, we need 420 watts. The projector, we need 1200 watts. The coffee maker is 900 watts. Stereo is 660 watts. What do they want me to find in the next column? Okay, what do I know? I know power. I'm just going to leave a blank. Cole, you're right. I know voltage. I want to find current. Cole, is there an equation that has current and power and voltage in it? And please, God, let it have the I by itself? Oh. What's the voltage in every case here? And the power is going to change for each appliance. I'm going to get my calculator out. The first one, it's going to be 420 divided by 120. It's going to use 3.5 amps. Is that right? The projector is going to be 1200 divided by, I think it's going to be 10. Yeah, 10 amps. The coffee maker is going to need 900 divided by 120. 7.5 amps. And the stereo is going to be 660 divided by 120. 5.5 amps. Okay. Oh, what does the next column want me to find? Matt, what does the next column want me to find? Which is which letter? R. Oh. Is there an equation that has the R by itself? Yeah. What? Don't help them out. You got to. But by the way, please don't tell other people, because I need everyone to be able to find these equations. R equals V over I. Yes. And what's the voltage source for each of these, Matt? And the I think we just found here. We can find each resistor now. This is a multi-step question, but we can. So it's going to be, for the first one, 120 divided by 3.5. 34.3. I can't make these work out evenly all the time, sorry. 34.3 ohms. That's my ohm symbol. 120 divided by 10. 12 ohms. That one I can do in my head. 120 divided by 7.5, 16 ohms. $120 divided by 5.5, I doubt this will work out evenly, 21.8 ohms. Really what I'm saying is power, current, voltage, resistance. How many fingers am I holding up? How many variables is that? 4. If I give you any 3, you can find the 4th with those 2 equations. Tensei, you're having your party. Turns out, in a standard household circuit, it can only handle 15 amps of current. Can you run all of these from the same extension cord? Nope. What will you do? Blow a breaker. You blow a breaker. So you have to revise your party plans. Which appliances can you run from this extension cord at the same time? Projector and blender? That would work. Sorry, which one? Yeah, that'll work. Add them up. It's at 13. We're still under 15. Any others? I think anything with the blender. Stereo and blender works. Coffee maker and blender works. Can you run 3 appliances successfully in any combination? No. Tensei, what you'll need to do is you'll need to get a separate extension cord, and it has to run to a completely different wall outlet, and that wall outlet has to be on a different circuit of your house. Because you may have noticed some plugs, even they're on separate sides of the room, actually it turns out they belong to the same breaker. When the power blows, they both go off, right? It all depends on how your house is wired up. I have one plug in my house. It's a bad plug. There must be something upstairs. I live in a basement suite. There's something upstairs. Those people must have a big appliance plugged into there, because that plug right there is where I would prefer to have my microwave. My microwave blows it every time. So I have my microwave in a crappy location, and that's fine. I can deal with that. Not that big an issue. Is that okay? So this is, again, Mason, why, if you've ever blown a breaker, this is what's going on. Hopefully, kind of, oh, didn't know that. Now you know. 15 amps is your standard household plug. Oh, Cole. Stove and dryer, that special plug there can handle 30 amps. It needs to, because it has to move a lot of current and heat around. And that special plug there puts out 240 volts, twice the voltage, as opposed to the standard 120. Okay. A typical blender uses 300 watts. It's plugged into a 120 volt outlet. Find A, the current it draws, and B, the resistance of the blender. You know what? Kevin, how many things is this question asking me to find? Psst. Psst. You know how I know? Because there's a part A and a part... So how many things is it asking me to find? You know what? I'm going to be clever. There. Again, I feel better. I've planned my attack. I'll find the first thing on the left and the second thing on the right. In fact, you know what? I would even go like this and like that. Sound good, Kev? Kevin, in part A, what's it asking me to find? What letter do I use for current? I. I equals question mark. Go back, look at numbers now, Kevin. What's the first number that we run into in this question? What's that 300? You ready? Listen close. What's that 300? Which is a measure of? In other words, what letter do I use for that? That's the unit. R is resistance. Sorry, this is not resistance. What do I measure in watts? Power. Don't worry, that's brand new today, Kev. No problem. By the end of the homework, you'll have that memorized. What other number do you see, Kev? You see why I said voltage is the easy one? Because it's volts and voltage. Guys, cut it up. Kevin, please tell me, is there an equation that has the I by itself and has a P and a V in it? Can you read it to me? Yes. Where P was 300 and V was 120. By the way, you'll notice I'm doing the insert sometimes on the same. What I am saying, I'm going to do all 4 of these steps. And heck, let's crunch it. I think I can do that in my head. 2.5? Yeah. I can do decimals in my head. And it's current, Kevin, amps. Kevin, are we right? Did we get the right answer? Say yes. Then I say to you, touchdown. There. Cool. Evan, what does B want me to find? Oh. R equals question mark. Evan, have I turned the page? Say no. Then you know what? I'm not going to read DFIC. I have it right here. I'm not going to list my data. It's right there. I'm not going to make you do that. So someone asked, do you have to write that? No. If I've turned the page, I usually will, because I don't want to have to try and remember stuff from the previous page. It takes 1 second. Okay, Evan, what equation?
R equals V over I.
Oh, that works. Because I found I from part A, I can now, by the way, I had to do it in this order. I couldn't have done B first because I wouldn't have known I. But now I can say, hey, R equals V over I. Evan, what's the voltage?
120.
Over. What's the current? 120 divided by 2.5. I should be able to do that in my head. Divided by 48? Yes? I can do math in my head with that. 48 what? Okay. Touchdown. How many more am I doing? Oh, we got a bunch more still. Okay. Oh, and multi-steps. Okay. Try this one on your own. I'm going to freeze the screen. See if you can do this on your own. I'll give you a hint. Since there's a part A and a part B, Brady, I would cleverly do that. And I'd probably put part A here, and I'd probably put part B there. And again, it's weird, Martin, but I feel better. I've written something down. It's not blank. I'm more relaxed. Go figure. But it works that way. Franz, you didn't just stick your headphone in your ear foolishly, did you? No, I don't think you did, because I'm still teaching. It's not? Oh, I'm sorry. I thought I did see it. My bad. Yeah, quick like a bunny. So guys, try solving this on your own. Try this. You can talk to your partner if you need to. I'm going to freeze the screen. See if we can get the same thing. Less giggling, more working. You already done? Nice. Cole, am I right? Yeah? I did the first one in my head, but the second one I wimped out and used a calculator. Franz, I swear I'm seeing a headphone in your ear. I was right. Leave it out.
Oh my goodness. Oh no. Oh my.
Ah! Alec, candy for you. What? If Mr. Dewick was clever, he would have said something like, it's worth memorizing what units go with what units, and yeah, okay. Did you all get 192 volts? Josh doesn't have a headphone in his ear either. Guys, not what I'm teaching. And did you all get, 7.68 amps, which at least isn't the yucky repeating decimal like it sort of it terminates, yes? Is that right? So here's my question. If these numbers are accurate, I've looked them up on the dryer at my house. Could a dryer run from a standard 120 volt outlet? How many volts does it need? 190. So now you're starting to see why certain things plug into certain stuff. Okay. For the what? Oh, is someone working ahead? Oh, okay. Yeah, 8 hours, if I want to change it to seconds, it's going to be 8 times 60 times 60. Or most of my physics kids, because we have to do this once so often, have memorized that it's 8 times 3600 because they get tired of going 60 times. Or they really cleverly go 8 times 60 squared, which is the fastest way to do it. We're going to get this far. We're going to finish this one. Then we're going to press pause. I'm going to give you part 1 of the homework. A PS4 uses 140 watts of power while playing games, which is true. How much energy is used when playing a game for 8 hours? Well, Danielle, my first question is, what's this question asking me to find? What letter have I used for energy? By the way, are you cluing in why in math we teach you algebra? Because it sure is nicer to use letters and not have to write out the word energy every time, or the word voltage every time, or the word current every time, or the word power every. It's a great, Matt, it's a great shorthand. So the reason we do so much algebra in your math classes is stuff like this. Sorry, what'd you say, Danielle? What else do I know? Power is what? And what else do I know? Problem. What's wrong with the time here? Hours. So I'm going to have to go times 60 times 60, or times 3,600, or times 60 squared, whichever lazy method you want to use. But you got to go to minutes and then to seconds. Danielle, please tell me that there's an equation that has an E, a P, and a T in it. What's the equation? And Danielle, I'm so lazy that I didn't even bother calculating what time is. I just dropped that expression right down into my equation, and I said, I don't really need to know what the time is in seconds as long as I do it right on my calculator. So I'm going to go 500,000 joules. This is a problem. This is a problem. The is that, am I right? You guys get 504,000 joules? Then you zigged somewhere. Am I wrong? Did I miss? Hang on. You know what? I zigged somewhere, Mr. Dewick. I forgot to go times by 8. Well, that was dumb. How about 4,030,000? How about that? Is that right? 4,032,000 joules. Mason, there's a problem with that. The problem is your parents' electric bill, they're charged on how much energy they use. But if they got an electric bill that said that you had used 15 million joules, they'd freak. A joule is too small. And so next class, we're going to talk about how a different way to measure energy that doesn't give you such big numbers so that parents won't, or that whoever's paying their electric bill won't freak out. So we're going to temporarily, as a lesson, pause here, but here are the questions you're capable of doing that are attached to the homework already. Okay? On a separate piece of paper, right now, you can get a head start on number 1, number 2, number 3. I take that back. Can't do 3 yet. You can do number 4. You can do number 5. You can do number 6. We're going to pause with that. So you don't have to go in order. I'm going to assign the rest of this next class, but you can start this on a piece of paper. I realize I've temporarily skipped 3, which means you'll do number 3 later on in the homework. That's okay. I'll figure it out just fine. We'll pause with that. We'll pick up with this next week, maybe, although next week because you guys have next week Thursday and Friday off, and it's a long weekend for you again. You know what? I think what we might end up doing is watching a Mythbusters video next. Well, we'll see. Play it by ear.